All right, a lot of people have asked me what's it take to do PICO ballooning. You know, I've gone into and showed you the little tracker we built with the solar panels, and I'll put that in a different video for you. I want to show you kind of what we do with the balloon and how and how much time we spend on it. It's pretty important. There's only a couple balloons out there that will work. You've got to have a balloon that's not stretchy. It can't be latex. It can't be a weather balloon. They're made to destroy themselves as they go up. These balloons are 1,000th or 1 mil, 1,000th of an inch thick, and once they expand out to their volume, they don't expand anymore. And once that happens, then the balloon stops rising, and that establishes the float altitude. Now, this is a balloon we have here that we're filling up with air. We're just testing it, make sure it doesn't have any leaks or no rips, and we're testing the pressure. And a lot of people test these up to about zero point 0.4 psi. Zero point 0.4 psi is about the maximum. If you go over that, you're going to pop the balloon. I usually try to go up to like 0.3 psi or whatever. That gets it pretty tight. And at altitude, your pressure typically isn't but about 0.17 to zero point 0.2. So testing at 0.3 is pretty good. So let's look at this and see what we've got here. So here I'm putting air into it. And I'm going to measure how much pressure we've got. And you see right here, I have a homemade manometer. And this manometer is just a piece of plastic tubing in a U shape, and we put some colored water in it. And the manometer has been around about 400 years. It's useful for measuring pressure, PSI, low value pressure. For instance, every inch of water rise equals a certain amount of PSI. So I can look at this. I can fill this balloon up and keep putting pressure into it, and I can watch the manometer here as it increases in inches. 4, 5, 6, 7 inches, and so forth. And I can tell exactly how much pressure we've got in the balloon. So this is a manometer here. Now I put a valve in line with it so I can turn the manometer off, because if I don't turn the manometer off, you can see a little valve right there. If I don't turn the manometer off, when I put air pressure into that balloon, it also goes down that hose, and it will blow the red liquid out of the tube, and it will actually blow it all over the ceiling. So I made that mistake a few times. So you got to remember, you don't pressurize a balloon with the manometer turned on there. Let's see. Okay. So there it is. The input to this balloon is very small. I'm using a piece of heat shrink there. That's probably about 1/8 inch heat shrink that's in the filler tube. And I think you can hear me putting a little air in there. And then I'm going to check it again. I turn the manometer on, and I read the pressure. And it's showing about a little under, 5 inches. And I have a chart there that tells me, how much pressure. Now, the way we tell how well we're doing with the balloon, we measure the circumference with a string, and that way it will give me the exact volume of that balloon. So I can get the circumference there. I can measure the circumference with a string, and then measure that with a tape measure. And then there's a formula you can use. Circumference can be converted into cubic meters per volume. So once we know the cubic meters in volume, that helps us to go into our spreadsheet, which calculates how much gas we put in and so forth. That balloon right here is a 32-inch balloon. It's not going to expand really any much bigger at all. It's going to stop expanding. That 32-inch balloon there is about 0.320 cubic meters. So that's the volume. And of course, you know, as we put gas in it when we launch, we don't fill it up tight. We put very little hydrogen in it, because hydrogen is going to expand as as it goes up. Now, next step here, I've got to take the air out. We got to get every molecule of air out of that envelope because we don't want it in there mixing with our hydrogen. So to get it out, I'm taking a shot back there, and on the hose that I use for input, I also just suck it out there. Now, that took quite a while to suck that out. And also, let me say this: once I expanded that balloon, I could see the circumference getting up around 103 inches, 104 inches, and I left the balloon tight and I let it set a couple of days. And as it sat there, stretched out kind of tight for a couple of days, it kind of stretched the balloon just a little bit. So we're stretching it to the point where it's not going to stretch anymore. So I think my final measurement was the circumference was 105 inches around that balloon. Here I am making the attempt to take the air out. It probably took close to an hour to suck the air out because, again, I'm using a little 1/8 inch tube, a piece of heat shrink. Just using a shot back. Hope that's not too loud for you. So I can vary the rate of suction just by putting my hand around it. So you can see right there, it's not going down very fast at all. I can vary the amount of suction on it by putting my hand around the vacuum hose there and kind of regulating how much suction we may get there. I hope that wasn't too noisy. Let me see if I can get a quieter spot here. Let's see. All right, that's a little quieter right there. All right, you can see we're sucking it out. You can see how slow it's going down right there. Going down pretty slow. Again, it took probably an hour just to get that air out of there. You can see it's getting pretty flat here. We're actually going to suck a vacuum, and we're gonna try to get every little bit of air out of there that we can. Again, this balloon is very delicate. You have to pretty much handle it with kid gloves or wear gloves. Actually, if you don't, you can damage it real easy. Okay, so now we're going to talk about how do we measure the amount of hydrogen we put in. Well, we know the volume of the balloon. We've taken our spreadsheet. We put all the numbers in. By the way, that's our hydrogen tank right there. We get that from a gas supply shop here in town. So we're gonna try to put some gas in. It just takes little small squirts because we're not putting much gas in. We're going to end up with only 7 grams of lift. For instance, if our payload is 10 grams, we're going to make that balloon lift 17 grams. So that means that balloon is going to lift the 10 gram weight, plus it'll have 7 extra of lifting power. So there I am putting the little tube in the balloon again. We're going to put some just quick squirts of air, not of air, of hydrogen into the balloon right there. Now, you don't have to worry about it until it starts rising. See, it's still laying on the table there. So once I get enough in there that it starts rising, then I need to be very careful and check it. Because if we overfill it, we've got to take some of it out. We do not want to overfill because it will go up and it will burst if we're not careful. So you can see it's coming in slowly. It's starting to rise a little bit right there. There we go. It's amazing how hydrogen gas rises like that. All right, so let's listen. You hear that? Just psst, one little squirt, 2 little squirts, not much. All right, and once we do that, we're going to take the filler tube. I'll put a little bit more in. Once we do that, we're going to take the filler tube out, and we're going to measure the lift. Now again, if our tracker and antenna and everything that goes in the balloon, if let's say it weighs 10 grams, and we want 7 grams of lift, we want this balloon to lift 17, the 10 plus 7. All right, so I don't know if I'm there, but it doesn't take much to go over. So I'm taking the filler tube out. And what we're using here are some scales. These are gram scales that are found around the house. If not, you can order them on eBay, pretty cheap, probably 15 bucks. Now on the balloon here, I've got some weights to hold it down. You can see it kind of a little piece of metal there to hold that balloon from taking off. And we also use those weights when we go out in the field to launch, so we don't by accident let the balloon go before we connect it up. So there we go. I'm gonna put the scales on something flat, turn them on, get them zeroed out, and what we've got is a paper clip taped to the scales, and it's zeroed out. And what we do, we hook the balloon on that little paper clip, and it pulls up on that scale, and it tells us you're at, say, minus 10. So if we're at 10, we know we want 17. 10 plus 7 is 17. So we want, we'll have to put a little bit more in there. You can see it still looks pretty empty. Not much in there, but we're getting close. Believe me, we're getting real close. There's the scales. Looks like we've got about 10 grams lift. I think on this one we were shooting for, we had a heavy tracker. The tracker was about 15 grams, so we wanted 7 grams of lift, so 15 to 7 would be about 22. So we're shooting for somewhere around 6 to 7 grams of free lift. So I was at 10. We need to go up to 22, so we're putting the filler back in. We're going to put just a couple quick squirts in. You might listen. One. That was one squirt. Come on. We're going to measure. We're going to measure that one squirt. We were at 10. Let's see what we got. All right, we zero the scales out each time, hook the balloon on. And the reason you have to do this inside, if the wind is blowing the balloon around, you can never get the reading because the wind will whip that balloon around, and the scale will be going, 10, 12, 15, 8, it'll just be going up and down because a gram is not very much. All right, so obviously it didn't have enough. Here we go, another little bit of squirt. Here we go. Let's see what we get this time. I might have put too much in. It's still pretty flat. You can see it doesn't have much in it. And I got to zero the scale. We're going to hook it on the paper clip, and we're going to see what the weight is, what the lift is. Here we go. Remember, we're looking for 22. And what is it? 22. Will it be close? Let's see if we must still be a little bit low. So man, now we're getting close, and it's getting tricky here. So we put the filler tube back in. You're going to hear short bursts now. I may have overdone it. Let's see. $23.5, and we were shooting for 22. We were shooting for 22, and we got 23.5. Now, I think I left the filler tube in. I turned the balloon upside down, and I squeezed a little bit of hydrogen out into the shop there to get what we wanted. Now we're out at the launch site. We're out at the launch site. I'm unrolling the antenna. The antenna is a vertical dipole. It's trapped for 20 and 10. This is the first time we ran a dual band tracker on 20 and 10. If you notice there, you can't see the wire. The wire and the string, the fishing line is so thin and so small, you can't see it. It's very difficult to see. And you got to be very careful. The solar cells here can break. If you sneeze, they'll break pretty much. Okay, so I'm tying the top half of the antenna. So the dipole, half the dipole goes from the tracker up to the balloon, and half of it hangs below the tracker. So now I'm tying the string and the top half of the antenna to the balloon. Again, you can see the weights on there to keep us from losing the balloon. We come close to losing a balloon a time or two.
See this line here, man. It is so small.
You can see it looks like I'm not tying anything, but I really am tying the antenna onto the balloon here. We'll do a good double knot there to make sure it doesn't come loose, and we'll be ready to launch. Okay. The thing you got to watch out for, don't step on the antenna and break it. And you can't see it there, so you got to be
this is
really
W5 KUB 118. We're launching this for the Arkansas River Valley Amateur Radio Foundation over in Russellville.
Now, one of the things, all this takes a lot more time than what you're seeing here. Probably to stretch the balloon to its maximum, to where it's going to stop stretching. It might take you, 3 or 4 hours, and then again, you want to let that kind of set in for a day or two, and let it kind of do the stretching on its own. And another reason we fill it up with air before is this balloon comes all folded up. It's kind of like saran wrap, and all the folding kind of sticks together. And we're afraid when it gets up there at 30, 40,000 feet at very cold temperatures, it might not want to open up very good. So we want to make sure that we open it up. Also, when they make the balloon, the seams, they stamp it with a machine to make the seams, and sometimes different layers are kind of stuck together. So we want to make sure it's filled out good. That takes, you can spend a couple of days on that. And then you can spend several hours in getting the gas volume in there correctly. So, and this doesn't count all the time to build a tracker, build the solar panels, test it outside, program it, and so forth. So, you got 3 or 4 days, maybe a week to get a flight ready. But we're fixing to launch this one right now. It's going to be a cool launch. Nice day. You can't launch. Also, you cannot launch if there's any clouds. If that balloon gets any moisture on it, it will come down. It'll be a failure. It'll be a disaster. So you gotta launch on a clear day. And it was almost no wind that day. On a windy day, you got to be careful. You'll tangle it up in some trees, 100 yards away. So we were real lucky on this one. So here we go.
Yeah, be careful. Take your thumb off the sails, man. They will break so easy. All right, Ed, if you'll take this, go ahead and lay that down. There you go. And if you'll take this, I'll take the tracker. Let's get it. We're gonna give you a countdown. And Ed, I guess just let it go. We got 5, 4, 3, 2, 1. Here we go. And we have liftoff. And it's already taking the tracker.
There we go. You can see the tracker hanging about 20 feet below the balloon. That top half of the string here, that's the top half of the 20 meters. And at 20 meters, half of it hangs below that. I want you to watch how far Ed's camera zooms in and out on this balloon in a minute. It'll be coming up.
This thing's over my head straight up, man. That's good.
It was a beautiful day for launch, let
At
me tell
least it's
you.
above the trees.
Watch when he zooms out in a minute. You'll see how far the balloon has traveled.
Where is it? Oh, I see. Oh, there it is.
We're almost going into the sun. This was launched on Saturday morning at 9 o'clock, and it's heading a little bit east-southeast.
Zooming out to see how far it is.
Look at that zoom. Watch this zoom.
Come
Look
on.
at that. Look at that. Let me see if I can repeat that zoom. Watch this. Watch this.
Zooming out to see how far it is. Come on.
If you look, you're going to see the tracker hanging below it here. Now, when this thing gets up in the jet stream, we were doing 145 miles an hour. And it's not really swinging around. You know, everything is relative. The tracker and the balloon, they seem like they're still. They're both moving at the same speed with the wind. So the tracker, there's the tracker right there. You can see it below. The tracker's not blowing all around under there. I'm sure there's some movement under there, but it's pretty steady. Probably just about like that right there.
That's 2 minutes and 30 seconds in flight now.
That was a good launch. So, I didn't cover it in this video, but that's the tracker we build. Actually, we started building those from scratch. We had the boards made, and we ordered all the parts. Parts were really, really small. We had to use a microscope to build this. And in the meantime, the PCB board company that we have that was making our boards actually is able to put these trackers together and build them for us with their pick and place machines. So it comes back now very professionally built, under the way electronic boards are built now by board manufacturers. So, but that's a picture of the tracker right there. And there's a shot of the a solar panel. We've got eight cells. Each of those cells is supposed to be 1/2 volts, so 8 times 5 should be 4 volts. The problem is that when you get up high, very high, above the clouds, you got a lot of ultraviolet light and different things. And those cells actually put out more than 1/2 volt. Actually, they were putting out about 0.65 volts each. So our maximum voltage with 8 cells was about 5.2 volts. And we didn't want anything higher than that, because some of our parts on our circuit board are only rated at 6 volts. So this is the second build for this launch. The first build, I had a trouble with the solar panels. Didn't seem to be working quite right, and I accidentally broke one of the cells. As mentioned, these cells can break if you look at it cross-eyed. They're paper thin. So one was broke, so I brought it in to replace the cell, and when I brought it in to take that cell out, I broke a second cell, so I replaced them. Still having problems with it, so we rebuilt a brand new 8-panel, a little bit thicker support here platform. It's about a 1/2 inch thick styrofoam, and that's what we went with. So it took several builds, and it took a lot of testing to make sure you don't want this thing put up in the air if it's got a problem, because there's no way you can fix it. So we just, on this one, we ran out of room on top to put the tracker. So we just put the tracker, glued the tracker to the side of the styrofoam. That's typically what you can see. Let me back it up. That's typically what you can see right there on a good flight. This flight here, this our last flight was up 450 days and went around the world about 25 times. So that's kind of the deal here. Just wanted to tell everybody just to tune in and watch our show. It's called Amateur Radio Roundtable, 8 o'clock p.m. every Tuesday night. And you can go to w5kub.com and you can watch the show there. And also there's a chat room here. You can chat directly with us and other viewers. We're also on YouTube. We're also on x.com. And we're also on Facebook with our show. And in addition to that, our show is transmitted on international shortwave station WBCQ on 7490 every week. Plus much more. Join our Facebook group. We got a great Facebook group. It's called W5KUB, and it has about 14,000 members. And please subscribe to our channel if you can there. So that's kind of the scoop on this last launch. We hope you learned something there. Thank you.